Let's talk about topic 6, prerequisites, just the beginning stuff that we need to get into before the crux of our unit. Inequality notation. We need to know how these are read. Some of us get this, some of us don't, but if it kind of looks like an L, like this first one, it's less than, and greater than would be the other way. We always read left to right, so x is less than 4. It's just the way that that goes. It's comparing x to this number and all the other solutions. Also, when we graph them, they're open circles because they're just less than, they're just greater than. These symbols that represent a number is not included in a solution set. For example, you must be under the age of 18 to be considered a minor. Solution set for this would be x is less than 18. Not less than or equal to, because if they were 18, they wouldn't be a minor anymore. We use the less than symbol because you can be any age up to 18, but cannot include 18. Already said that. Again, to be an open circle. C, now we have less than or equal to. So the only difference here is that we color in our circles when we're graphing. These symbols represent that a number is included in a solution set. So, for example, you must be at least 35 years or older to become the president. So the solution set for that would be x is greater than or equal to 35. 35 is the smallest, so everything's greater, so it's x is greater than 35. And we would use a closed circle because 35 is included, because that's when things start. So let's answer these couple questions here. Write inequality that represents ages that a person is considered a teenager. Well, it's 13 to 19. So we'd write 13 is less than, less than or equal to x less than or equal to 19. It's included because 13 and 19 are also teenagers. Write the following inequalities in words. So this example, x is greater than 6. Well, x is greater than 6. It's exactly what I say. And some of you say that as well. So number 1 is x is less than or equal to -3. Kind of ran out of space there. Number 2, x is greater than 18. Notice it doesn't mean equal. There's no line underneath the inequality sign. And then the last one, x is less than or equal to -1. That'd be x is greater than, because they kind of flipped it around, to -1, and is less than 5. Not less than or equal to, because it doesn't have the line underneath. Alright, write the following statements as inequalities. X is greater than -4, so greater than looks like this, -4, but less than or equal to 7. Except it's kind of weird to write it like that. I think probably be easier to write it like this and the way it should be. So we have -4 is less than x. Cool. And x is less than or equal to 7. So we have a line under the, or geared towards the 7, and the -4 is just the less than. All right, number 2, x is less than -12. X is less than -12. Nothing too crazy going on there. Number 3, x is greater than 6 but less than 10. So now I'm going to not have the problem I did in number 1. It's greater and less than, so it's in the middle. So x is greater than 6. So because it's kind of flipped around, the 6 is over here. Because x is bigger than that. This says 6 is smaller than x, which means x is bigger than 6. But less than 10. So x is less than 10. Not including either point, because they weren't less than or equal to or greater than or equal to. So that's how we write our inequality notation. Let's keep moving. Domain and range. Domain. The set of all possible input values x values of a function. So it's all our possible x values that we can plug into the equation. The range, similar definition, the set of all possible, now the difference comes here, output values of a function. So it's all the possible values that we can get for an answer if we plug something in. And you'll see, well, we'll just continue on. Identify the domain and range for each function. Well, the domain for 1, because, let me switch colors here, gonna blend in there. Because that graph keeps going that way, and that keeps going that way. Or the green absolute value function keeps going those directions. Down, but also those directions. So it goes all the way to the left, all the way to the right, so it's all real numbers. Now for the range, well, going down, it goes down forever. But going up, it has a stop point. There's a highest point at 2, because we're looking at the y values. So y, it can be 2 because it's not an open circle. So it's y less than or equal to 2. Now looking at number 2, the domain, again, it's very clear to see that it keeps going to the left and it keeps going to the right. So all real numbers are our domain. Now on the y-axis, you tell this is kind of going up the whole time. And this keeps going down the whole time. So it keeps going up and it keeps going all the way down. So again, that's everything. That would be all real numbers. Which is weird. We usually don't have all real numbers for our range. Something we're familiar with. Number 3. Again, it goes all the way to the left and all the way to the right. So for our x values, or our domain, it's all real numbers. Everything works. Now, the range, not quite the same. We have a lowest point of -4 included, because there's no open circle there. Now, is x greater than -4? Is it above it? Yes. So x is greater than or equal to -4. Oop, not x. Y, we're talking about range. All right, let's look at this one. Number 4, the domain. It's not everything. It doesn't go to the left at all. Our domain starts at 3, and it just keeps going that way. So our x is greater than or equal to 3. Whoop. 3. Because at 3, or anything greater than 3, our function's going to be there. If we went to the left, there's already nothing here. And it's not going to get there. It stops right at that 3. So now looking at our range, well, it's not going up forever because it stops at 0. We're looking at the y value. So it's y, something with the 0, and it's decreasing. So numbers that would work, 0, -1, -2, -3, -4. So y is less than or equal to 0. And we'll keep practicing these. All right, we got 5 more. Let's get them done. Number 5, domain and range. Domain, our x values are all the way to infinity, all the way to the left. And the domain stops. Kind of hard to tell exactly where it's stopping. Actually, not so much. It does keep going left as well. Very slightly, if you can tell. So our domain, once again, is all real numbers. Our range, well, it doesn't go all the way down. It goes all the way up, but it doesn't go all the way down. So the lowest value, the lowest y value, is 0. And we don't know if it actually gets to 0. It's kind of close. I think I'd probably take it. Not going to be, y is less than 0 because there's nothing, you can't be 0 because 0 is not on our graph. It's right down here. Number 6, a line. This is pretty straightforward. It goes to the left forever and the right forever. It goes up forever and it goes down forever. So both domain and range are all real numbers. Letter A, our absolute value function. The domain, well, it goes all the way to right, goes all the way to left. So again, that's all real numbers. But our y's, no, they don't go all the way up and all the way down. They go all the way up, but they stop at -4, or really start at -4, I suppose. So all the solutions for this function, for this absolute value, all the y values are greater than -4. So y is greater than or equal to -4 because there wasn't an open hole there. So we're good there. Hold 1 second. I think. Yeah, it's not -4. It should be 0 because that's the y value. So y can be anything, including 0 and up. Letter B here, again, it's a line. Linear functions always go right and all the way left, all the way up, and all the way down. So, again, it's all real numbers. Last one, it's got 2 parts. So we're going to have 2 domains. We can't really tell, but I'm going to tell you. As these go up, they get closer and closer to 0. But they don't actually get there. So on this left side, x is less than 0. And it's not less than or equal to, because we can't get to 0 because it just gets real close and keeps going real closer and closer and closer. But at the same time, we have over here on the right side, but it's the same thing. However, x is now greater than 0 because all our values for x are to the right of that 0. And then the range, we can see that the range is on 0 here on our y-axis. Now, is it greater than y? Or is y greater than 0, or is it less than? Well, greater than, because it's above y equals 0. Because it goes up. So 0, or y is greater than 0. And that's some basics to help us for this chapter.